All right, we are doing our note section 7 today, which starts on page 15, or actually 16. And we're really talking about some more shortcuts today. So your proportions, you can set up the sides, and if they're proportional, then they're similar. But there are some times where you don't have to set up the proportions because they're always going to be similar. But that doesn't mean you can't. You could still check that way if you really want to. So one of those ways is divided sides. If a line is parallel to one of the sides of a triangle, intersects other two sides, then they're proportional. So right here, if you have a side that's parallel to another side inside, then these two triangles are similar. Your smaller triangle, TUR, is similar to triangle QSR. Okay, so if you have a triangle contained within another one and they're parallel, then they're similar. The opposite of divided sides says if a line divides two sides of a triangle proportionally, then these are parallel. So it's just the opposite. If these are similar, then you can say these two sides are parallel. Three parallel lines. If three parallel lines intersect two transversals, then the line divided the transversals proportionally. That means that since these are all parallel, these are proportional. So they're not the same length. You can tell that fairly obviously, but ZX over YW would be equal to XV over WU. Okay, so these sides are proportional and these two sides are proportional. And the last one, angle bisector proportionality. If a ray bisects an angle of a triangle, which would mean these two angles are congruent, they are the same measure, then the ray divides the opposite sides into segments whose lengths are proportional to the lengths of the other two sides. So here, AD over AC is the same as BD over BC. Okay, so they're not congruent, but they are proportional. Other proportions that will also work using dividing sides. So this one is the same as the first one where we have divided sides. So A over B would be the same as X over Y. A over C will be the same as X over Z. B over C would be the same as Y over Z. A over X is B over Y. C over Z. C over Z, and then you could pick A over X or B over Y, but let's do here A over X and B over Y. Okay, all of those would work for divided sides. Okay, and they're not actually talking about like a curve here, they're just talking about the total, just FYI. With those two sides, any combination will work as long as you are consistent with your ratios. And by consistent, we just mean if you do A over X, then you'd still have to do B first. You can't switch the order. With the third pair of sides, parallel sides, divided sides will not work. You must use definition of similar triangles. So what they're saying there is that you cannot use P over M. It only works with the other sides on the other legs of your triangle. Okay? All right, find the length of YZ. So let's highlight what we're looking for. So I can do 44 over 36 equals 35 over X. So we have 1260 equals 44x. So x is approximately 28.6. So that is rounded. It was a long decimal. That's okay. Find the length of yx. So right here. So this full length would be 16 plus x. And then we're trying to find x. And they give us a full length and 3. So let's do 3 over x equals 18 over 16 plus x. So when I multiply here, I have to distribute. So I would have 48 plus 3x equals 18x. So you have 48 equals 15x, which would be 3.2. Determine whether MN is parallel to GH. So to do that, their proportions have to be the same. This is just the opposite of what we were doing before. So if I do 56 over 48, then I can do 21 over 16, and these need to be equal. Okay, since they are not equal, MN is not parallel to GH. Okay, so I'm going to get rid of my marks. All right, find the length of TU. So since we have 3 parallel lines, and we know that because these all are the same angle, they're saying they're all congruent, then we know these distances are proportional. So if I have 9 over 15, I can do 11 over x. So that's 18.3 repeating. All right, solve for x. So I need this length, so I can do 6 over x equals 9 over 8. So I have 5.3 repeating. Solve for x. Okay, since we have these two angles are the same, we know that this triangle would be proportional to this triangle. So you have 3 over 7 equals 4 over x. So x is 9.3 repeating. Solve for x. So I need this little section. I can't use the whole distance for this type of problem. So this little section I'm going to call 20 minus x. So I would have 20 minus x over 11 equals x over 14. Okay, and don't forget you have to distribute that 14. So you have 280 minus 14x equals 11x. So we get 11.2 for x. Find the length of DC. So the whole thing is 14. So let's pick DC to be x, and then this would be 14 minus x. So I have 14 minus x over 9 equals x over 15. And again, don't forget to distribute here. So you have 210 minus 15x equals 9x. So then you have 8.75 equals x. Okay? All right, so that's it for your notes today. You're working on pages 32 and 33 for your homework.